Good day everyone. Today we are looking at trigonometric function, still on differentiation. Now when you are talking about trigonometric function, there are some basic rules that you must understand. Now if this is y and this is y prime, anytime you have prime, it means you are differentiating. So when you have sine x, if you differentiate sine x, it will give you cos x. If you differentiate cos x, it will give you minus sine x. If you differentiate tan x, it will give you sec x squared. You see that? So anytime you differentiate sine x, it will give you cos x. Anytime you differentiate cos x, it will give you minus sine x. Anytime you differentiate tan x, it will give you sec squared x. Okay? Having said that, let's assume you have something like this: y equals to sine 4x. And you want to differentiate. Now I'm going to be showing you the short method of differentiation first before I'll do the long method. So the y dx is going to be, differentiate this 4x, it will give you 4. Differentiate sine. Anytime you differentiate sine, it will give you cos. Then rewrite the 4x. That's all. So differentiate 4x, it will give you 4. Differentiate sine, it will give you cos, then rewrite the 4x. So if I have y equals cos 6x, to get my dy dx, I'll differentiate 6x, that will give me 6. Then differentiate cos, that will give me minus sine. You will have to bring the minus to the back, to the far back, then rewrite the 6x. Because if you differentiate cos, it will give you minus sine. Now if I have y equals to tan 10x, so if I want to get my dy dx, it's going to be differentiate 10x, 10. Differentiate tan, sec squared, then the 10x, you write it back. You see that? This square is a power, don't forget. So this is very straightforward. Now I expect you to pause the video and copy this. So don't forget, if you differentiate sine x, it will give you cos x. If you differentiate cos x, it will give you minus sine x. And if you differentiate tan x, it will give you sec squared x. Now if you have something like this, for example, y equals sine x raised to power 3, and then you want to differentiate. So your dy dx is going to be, differentiate this x cubed, it will give you 3x squared. Then differentiate sine, it will give you cos. Then rewrite the x cubed. You see that? That's the answer. Now look at, if I have y equals to cos 4x 5 minus 1. If you have something like this, so your dy dx here is going to be, differentiate what you have in the bracket. If you differentiate 4x raised to power 5, that will give you 20x raised to power 4. 5 times 4 is 20. Minus 1 from the 5, you have 4. Differentiate 1, that's 0. So by the time you differentiate cos, what will it give you? Minus sine. Always bring the minus to the far back, then rewrite the bracket. 4x5 minus 1. You have answered that question. Straightforward. Now if I have y equals tan 3x cubed minus 4x plus 1. Let's say you have something like this. So to get your dy dx, so it is going to be, differentiate 3x cubed, that will give you 9x squared. Differentiate minus 4x, that will give you minus 4. Differentiate 1, 0. Now if you differentiate tan, it will give you sec squared. Then rewrite the bracket. 3x cubed minus 4x plus 1. That's your final answer. You see that? Very straightforward. Now if I have y equals to sine 6x cubed, so what will be my dy dx for this one? Differentiate 6x cubed, that will be 18x squared. 3 times 6 is 18, minus 1 from the 3, 2. Differentiate sine to give you cos, then rewrite this back, x cubed. So I'm going to be giving you a lot of questions on things like this. You solve them. The ones you have challenges with, get across to me through the number on the screen. Now, having said that, the next one we want to look at is that let's assume that you have something like this: y equals 8 sine 5x. Look at this. So to get your dy dx, you are going to say differentiate 5x, that's 5 times 8, 40. Differentiate sine, cos, then rewrite the 5x. That's the answer. Now if I have y equals to 3 cos x raised to power 4, for example, now my dy dx is going to be differentiate x raised to power 4. It will give you 4x cubed times 3. That will be 12x cubed. Then differentiate cos. That will give you minus sine. Always put the minus at the far back. Then rewrite the x power 4. And that's it. Now look at if I have y equals 5 times 3x raised to power 4. Now to differentiate this, dy dx, I'm going to have differentiate 3x raised to power 4. You know that will give you 12x raised to power 3. How? Because 4 times 3 is 12. If you minus 1 from the 3, you will have 2. So then this 12x raised to power 3, multiply it with 5. So that will be 60x raised to power 3. That is 12 times 5 is 60. Then the x raised to power 3, put it there. When you differentiate term, it will give you sec squared. Then you will write this 3x raised to power 4. You see that? So if I have y equals 3 cos 4x squared minus 1, for example. So my dy dx here is going to be differentiate 4x squared. That will give you 8x. The 8x times 3 will be 24x. You know, if you differentiate 1, that will give you 0. Then if you differentiate cos, it will give you minus sine. Then you will rewrite the bracket 4x squared minus 1. That's the answer. So I expect you to do a lot of practice on this one so that you can be fine. Now the other aspect we want to look at is if we have something like this: y equals sine x cubed. Say something like this. So, you know, if I have y equals sine 3x, here my dy dx is going to be differentiate 3x, 3, differentiate sine, cos, then rewrite the 3x. This one is straightforward. But if the power, if it's a power, the 3 is up. Now when you want to differentiate that, your dy dx will be bring down the 3, then differentiate sine x, that will give you cos x, then minus 1 from this 3, that will give you sine x squared. That's the answer. You see that? So it means if I have y equals to cos 5x, my dy dx is going to be bring down the 5, differentiate cos x minus sine x. I told you always bring the minus to the far back. Then minus 1 from the 5, you are going to have cos x raised to power 4. You see that? So if I have y equals tan x power 9, so our dy dx will be bring down the 9, differentiate tan x, sec squared x, then minus 1 from this 9, tan x raised to power 8. You see that? That is the answer. But don't ever forget that if you differentiate sine x, it will give you cos x. If you differentiate cos x, it will give you minus sine x. And if you differentiate tan x, it will give you sec squared x. Okay, having said that, let's try all of these things I've done. You can do them with long method. So I'm just going to do two of them with long method, and then all the ones I've solved, I expect you to do them with long method. If you are hanging anywhere, please get back to me. Okay, let me take this first one and do it with a long method, because all these ones I'm doing are just the short method, which is also acceptable in exam. It's only that some lecturers might want you to do the long method. For example, if I have y equals sine 3x and I want to use long method to solve this, I already know that if my y is sine 3x, the dy dx is differentiate 3x, 3, differentiate sine cos, then rewrite the 3x. This is our answer. But let's use long method. So when you have this question, the first step, you will say let u be equal to 3x. Let u be equal to whatever you have beside the function. Then rewrite the question, y equals to sine u. You see that? Sine, I've replaced this 3x with letter u. So I just wrote y is equal to sine. Instead of writing it, because I've replaced it with letter u, so I just put u there. So from here, I have letter u and x. So I'll look for du dx. Now if you differentiate 3x, that will give you 3. Then here I have y and u. So let me find dy du. Now if you differentiate sine u, of course it will give you cos u. Why? If you differentiate sine x, it will give you cos x. So following your function, your composite function, dy dx equals dy du times du dx. And then applying this formula, dy dx equals, what's our dy du? Cos u times, what's our du dx? 3. So by the time I multiply this, my dy dx is going to be 3 cos u. 3 times cos u is 3 cos u. So eventually my dy dx is going to be 3 cos. What is the original value of u from the beginning? The original value of u from the beginning is u is 3x. So instead of me to write u, I will just put the original value. So 3 cos 3x. You can see it's the same thing when we do the short method. So all other ones that I've solved, try to follow this long method to do them, and then you will be fine. Now let me solve one of those ones we have solved before with a long method. Now if you have this, for example, you have y equals sine x cubed. You see this one? We want to do this one with long method. See the way we are going to do it. You want to differentiate this. So you say let u be equal to sine x. So this one is different. You will pick the sine x. And that means rewrite this question. Y is equal to, instead of writing sine x, you have replaced it with u. So you say u raised to power 3. You see that? U raised to power 3, because this is a power. So this sine x raised to power 3 actually means this. This is the original meaning. But you don't write it this way. You have to write it this way. So let sine x be equal to u. So it will now be u raised to power 3. So from here, I have letter u and x. What will be my du dx? My du dx will be, if you differentiate sine x, it will give you cos x. Then I have letter y and u here. So let me find dy du. So if you differentiate u raised to power 3, of course, that will give you 3u squared. You see that? Your normal differentiation. Now, using your function, dy dx equals to dy du times du dx. So your dy dx will now be equal to, what's dy du? 3u squared times, what's your du dx? Cos x. So by the time you multiply this, your dy dx will now be 3 cos x u squared. That is this 3, then this cos x, then this u squared. Then if you want to rewrite that finally, your dy dx will now be 3 cos x. Then, what's the original value of u from the beginning? Original value of u is sin x, but it has square, so you put the square here. You always put the square there. See the answer. And if you check the previous one that we have solved, we got the same answer when we used short method. So this is what trigonometric function is all about. Very direct. So I'm going to give you a lot of questions to practice, but if you have any issue, please get back to me. Thank you.